Hello, we are night.py, and in this video, we will be looking at questions asked in many fresher interviews. This question was asked in my second interview. The question was, compute the intersection of two arrays. Now, at that time, I did not know what an intersection was. So the interviewer expected me to know it, but I did not know. So for all of you there, intersection is the number of elements common in each array. So for example, if an array, let's take an array A equals and B equals like symmetry. B equals 3, 7, 8, 9, and 4. So 3 and 4 are common in the both arrays, and the intersection of two of these arrays is 2 because two elements are common. So it's basically the number of elements in common. Number of elements in common. Okay, we got that out of the way. The next thing you should do is ask the interviewer or anybody who's asking this question, what are the constraints or is there any conditions? Many interviewers look for candidates who ask this question. In some rare cases, they would select you even if you don't solve the question and ask these type of questions. Questions like, what are the assumptions or what constraint should I use? I asked the question to my interviewer and he told me constraint number 1. I don't like this bracket. Yeah, this is good. Constraint number 1. Assume neither array has any duplicates. That's constraint number 1. And constraint number 2. Assume you have any sorting or searching function already given to you. So these were the assumptions the interviewer gave me. So the second assumption gave me a clue on how to solve the question. And I got into solving. So basically, I have to define a function, it computes the intersection of the two arrays, and also, third assumption, I forgot. Third, so print the elements or output the elements which are common. And also, he asked me for the big O, the time complexity. Let's get started. Let's take these two arrays. They are in the same size and two elements are equal. Let's begin. So define a function, intersection, let's call it. Good name. A and B, two arrays. Yeah, I'm doing this in Python as well. So I have merge sort already here. Merge sort is my favorite sorting algorithm, so I'm going to use that. And I have binary search to search the element. I'll get to it. So first step, we are going to sort B. How this algorithm works is it computes the intersection by sorting one array and then iterating throughout the array, checking through binary search. So how are we going to implement this? Merge sort of B. So it's going to sort array number B. Define an element, inter equals 0. This will store the intersection. Define a for loop for I in A. The element I, the loop variable I will loop through A, every element of A. So at first I will be 1, and then 2, and 3, 4, and 5. If this is a simple if condition, this is the binary search function. If binary search of B of I is greater than or equal to 0, meaning it's true, intersect plus plus enter plus plus, and that's it. Return enter. So if we run this, oh yeah, sorry, Python, I forgot. Yeah, these are the pitfalls of switching through programming languages. Inter plus equals 1. Yeah. So if we do this intersection of a comma b of these two arrays, I get 2. So 2 elements are common. And now we have to print which elements are common. So for this, take another array, take another global array, le equals 0. Here, le dot append, it's a list, element is a list, append I, and we're done. So yeah, intersection of I, and then print le, look at that, 1 and 5. Yeah, that's different. Yeah, so I just, yeah, there's another technical difficulties there. Yeah, I put the element outside the cell here. Yeah, this is one of the pitfalls using Jupyter Notebook. So the intersection of A and B is 3 and 4. And the number of elements in common is, wait a second, 3. Here you go. Number of elements in common is 3 and 4. Yeah. Yeah, I made no errors in the program. The notebook gave away. Yeah, I didn't execute the cells in order. That's one of the disadvantages using Jupyter Notebook. Anyway, so it comes to the last question. What is the runtime? What is the runtime of this algorithm? Let's think about it. So I'll give you an example. First, we have to sort array B. So take this into merge sort. So to sorting array B takes big O of B log B. Yes. So B is the size of the array. So yeah, merge sort takes this much. Then for each element in array A, we binary search in array B. So here it takes log B times. So yeah, so for each element in A, we do this. So it takes A log B. Because binary search has a time complexity of log n, and you're doing it A times, so log A. So what is the time complexity of this algorithm? It'll be pretty easy. So the time complexity of this algorithm is big O of B log B plus A log B. Sorry. Yeah, this reminds me. A lot of candidates do this. They put n here. B log n plus A log n, because log n is common. And yeah, it's standardized. But yeah, this won't get you any brownie points. You have to put B log B plus A log B. You can't simplify it. Maybe you can. But yeah, keep it like this. You can keep it like this. Interviewer will be impressed. In the coming videos, we will teach you efficient methods to implement the binary search algorithm and the merge sort algorithm. Stay tuned, subscribe, like, and share the video. We have big plans for the future. Thank you. This is Night by signing out.